So after finishing this section, inshallah, you will be able to define the definite integral, what we mean by integrable function. You will be able to evaluate also definite integrals and to use known areas to evaluate integrals and to apply the to use the midpoint formula or the midpoint rule and to identify the properties of definite integrals. Let's revise quickly what we have done in the previous class. We have defined the definite integral just to be the limit of the Riemann sum. This is called, ya shabab, the Riemann sum. And the definite integral of a function f from a to b is just the limit of the Riemann sum. If you notice, it is equivalent to the definition of the area if the function is positive. If this limit exists, we say that the function is integrable. This is called the integrand. These are the limits of the integral, the upper and the lower limits. How to read it? It is the integral of f from a to b. The whole process is called integration. Keep in mind, this is just one symbol, ya shabab. That means the definite integral. This definite integral, at the end, it will be a number. So it does not depend on x. If you write it f of x dx or f of t dt or f of r dr, whatever, f of whatever d whatever, it will be, of course, the same number, same real number at the end. As I say, this is called the shabab the Riemann sum. So this is the definite integral is just the limit of the Riemann sum. And this is why sometimes they call this integral Riemann integral. I think we didn't mention this remark in the previous class. So what you need to know, ya shabab, also that this dx, usually we take the width of the subinterval to be the same. So the subintervals are of equal width. But of course, in some situations, you can have them with unequal width. But we will not discuss this in this textbook. Okay? The level of these such kind of problems is upper than the level of this course. Also, we say, the shabab, that the definite integral is defined for integrable function, but not all the functions are integrable. If you want to see some functions that they are not integrable, you can look at these two exercises. Now, how to guarantee that the function is integrable? The continuity is enough to guarantee the integrability of the function. If the function is continuous, then not necessarily only continuous. If it is continuous or it has a finite number of jump discontinuities. If it is continuous or has finite number of jumps, then it is integrable, which means that this integral exists. This exists. Yes, it is mentioned here. So the continuity is enough, طبعا. Now, this is, ya shabab, now what we are going to consider the formal definition of the definite integral. If f is integrable, then the definite integral is just the limit of n goes to infinity from I equals 1 to n for f of xi dx. طبعا xi here, it is this. xi equals to a plus I delta x. And this is delta x b minus a. We mentioned this before when we studied, of course, 5.1. So from now and on, this is the definition of the definite integral. Now, let's apply it to this example. We have a limit of a summation here. So we have a limit of a Riemann sum. This is a Riemann sum. Express this limit as an integral over the interval from 0 to pi. So the integral will be from 0 to pi. The question is, what is f of x? And we know that this is x. Now the question is, what is f of x? Can you compare? If you compare this with this, of course, you can see clearly that this is f of x. Because if you compare, this is delta x, this is f of xi. So this is xi, xi, xi. So this is f of xi. Just by comparing this with this, shabab. So it is clearly that f of xi here, it is xi to the power 3 plus xi sine xi. So this means that f of x, it is x to the power 3 plus x times sine x. So that just put this one here and you have your integral. So this is the integral of which function? It is the integral of x cubed plus x sine x dx. ولا أسهل. It is very easy. Okay, so let's now connect what we are doing now with what we have done in 5.1. طبعا what we know يا شباب so far that if f is positive, then the Riemann sum can be interpreted as a sum of areas here, because this is of course the sigma يا شباب here, the sigma of f of xi dot x, it is the sum of the areas of these approximating rectangles. Okay, but if you want to find the exact area, if by comparing this with definition 2, the previous definition يا شباب, definition 2, he means this one, sigma, the limit of the sigma when I starting from 1 up to n, when n goes to infinity. You will have, of course, comparing this with the definition of the area, you will see that the definite integral can be represented as an area under the curve from A to B. Okay, so this is, of course, ya shabab, the definite integral. This is the definite, this is the area. In this case, it is equals to the integral from A to B f of x dx. So this will help us to, instead of doing this limit and these approximations, we can just evaluate the definite integral and we will be able to find the area. But the question is this always true? The question is when a equals to the integral from A to B for the function f. Is it always true يا شباب? Is a equals integral from A to B f of x dx? Is it always true?
No.
No.
It's not always true.
Only greater.
When the function is positive.
When it is true? The question is when it is true.
Greater than 0.
When the function is
If
positive.
the function is positive, not always, positive on the interval that you will integrate. If it is, I think I mentioned it here. If it is positive on the interval of integration, when you integrate from A to B, if your function is positive, then the area will be identical to the definite integral. Okay? The question is, what about if it is negative? Or if it is sometimes negative, sometimes positive. It is not the same, it doesn't have the same sign. طبعا if it is negative, it is easy. If it is always negative, if the function is negative always, then the area will be the absolute value of the integral. Just find the integral and take the absolute value. This is not difficult. The problem or the question is, what about if f takes both positive and negative values? So here I'm integrating from A to B. From A to here, it is positive. Then from here to here, it is negative. Then it is positive again. So in that case, the Riemann sum is the sum of the areas of the rectangles that lie above the x-axis and the negatives of the areas of the rectangles that lies below the x-axis. Here we have look at the blue regions, ya shabab, the blue triangle, the rectangles. If you want to calculate the areas, of course, the area is positive. The area here is positive. The area here is positive. The area here is positive. It is an area. But if you want to calculate the integrals, the integral here will be positive. The integral here will be positive. But here it will be negative. The integral from A to f of x of dx will be negative. You will see why. We will mention this later, ya shabab. If the function is negative, then the integral also of this function is negative. Okay, from the definite integral I'm talking about. Now, what we can say that when we take the limit, when x, of course, when n goes to infinity, then the integral will be, in this case, will represent the net area, not the area, the net area. What is the net area? The net area, shabab, the word net here, it means total. It is just, think about it like the total area. So in this case, we can define the net area or the definite integral to be interpreted as a net area where it will be just the difference between the areas. A1 in this case is the area above the x-axis, and the A2 it is the area below the x-axis. Where it is, here it is. Okay, so if you have a definite integral, it will not be exactly equals to the area. It will be equals to the areas above the x-axis minus the areas of the areas below the x-axis, and this will be positive at the end, ya shabab, by the way, because it could be positive, it could be negative, but here, because this negative, this area here, it is positive, this area is positive, it could be the integral, the definite integral could be positive, could be negative, but for the area, it is always positive. Let's take an example. It is better to have an example, but before that, we need to recall, ya shabab, the sigma notation. We have studied this before. Do you remember? The sigma of I, the sigma of I squared, the sigma of I cubed. How to do that when you have a constant, multiplied by other quantities depending on I, and so on. Now, let's evaluate the Riemann sum for this function. You know the Riemann sum, it is just this one, f of xi delta x, okay? طبعا he said here taking the simple points to be the right, so it is the same. Now I starting from 1 up to n, and a is 0, b is 3, and n is 6, so we will take n equals to 6, which means that we will use 6 rectangles. So what we will start with, ya shabab, we will start with what?
Delta x.
Yes, we will start with delta x. Delta x, it is b minus a over n, so it will be 3 minus 0 over 6, it will be a half. Then we will do what? We will find xi. Xi, in this case, xi, it is a plus I delta x, so it will be 0 plus I times a half, so it is I over 2. So x1, we have here, ya shabab, 6. We need to find 6 i's. So we need to find x1, which is a half, x2, which will be plus. Just add a half, add another half, add another half. What is the half? It is the delta x, and so on. So we will start at a half, and we will stop at, and this is easy, ya shabab. If you look at your interval, you are going to divide it into 6 parts. So this is when you add a half, add another half, add another half, add another half, add another half. So what you will do, you will use the right end point. So you will start from here, and you will take these points. The only point that is excluded is the first one. Now you will evaluate the function at a half, plus the function at 1, plus the function at 3 over 2, plus the function at 2, plus the function at 5 over 2, plus the function at 3. Then you will multiply all of these by the delta x. What is delta x? Delta x is a half. So you multiply all of this by a half. This will give you approximately the area. But of course, we are not talking about the area here. We are talking about the Riemann sum. By the way, the Riemann also R can be represented, of course, the right endpoints. Also, it can be expressed or shortcut for Riemann sum. So it is R what? This is R6, because we used 6 rectangles. Here it is. This is exactly what I have mentioned for you, Shabab. Now it is a matter of calculation. Now, of course, you can do it without a calculator, as just integrals. But of course, for such kind of function, it is not easy. It will take time. So you need a calculator in this case to save your time. Now, this is, look at the Riemann sum, Shabab. It is negative. So can we say that this is approximately the area? The area, of course, in this case is negative. No, the area cannot be negative. So this means that we have, for this curve, we have some, you look at it, at some sub-intervals, it is below the x-axis, and then it is above the x-axis. So in fact, notice that f is not a positive function, and so the Riemann sum does not represent a sum of areas. لأنه ال f يا شباب إذا كانت ال f of x negative, if you multiply it, f of xi, let's say, if you multiply it by delta x, it will still negative because delta x is positive. Always delta x in this case, b minus a is positive because b is greater than or equals a. So it is negative because of this. So we are adding some negative values to each other. Now, what was B, part B? Part B, it was about evaluating this integral. Exactly, not approximately. So what you need here to mention that this does represent, I will mention this after evaluating the integral, no problem. Now let's evaluate now the integral in general, not with n equals to 6, no, with n in general. So this is delta x. You need to find xi, here it is. Now you need to find f of xi, so you will replace xi by 3i over n. Then you will multiply delta x by f of xi. Here we are. And you will, of course, take the sigma and then take the limit. This will be equal to the integral. By the definition, the integral is this.
Doctor,
Now, what is, yes.
if I solve by integral directly, it is the same answer, right?
This is not the time to do that, yes. Of course, it will be the same.
Okay.
Of course, it will be the same, but we will see that later. For this sections, we need to practice it by using the Riemann sum, because you, for sure, you will have questions to do it with this way, okay? You can use the integral as a kind of check. We will see that later. So this is the function, Shabab. This is the function. This is 3 over n. It is outside the sigma because it is a constant with respect to I. Now, what you need to do, this will be 9, 3 to the power 327 over n cubed, I cubed. Also, this is a constant. You can get it out here and distribute the sigma as shown here. We distribute the sigma. What is constant, we kept it out. And then we will use, of course, what we have learned before in the sigma notation. What is the sigma of I cubed and what is the sigma of I? Here it is. This is, of course, what we have done before. And now it is just a matter of simplifying and taking the limit when n goes to infinity. You can see clearly here that you have here n to the power 4 and also here n to the power 2. It will be cancelled with n squared here and n squared there. So you will have this at the end. Similarly there. Now when n goes to infinity, this will be 0, this will be 0, and you will have 81 over 4 minus 27, which is negative 27 over 4. Look, the definite integral can be negative. Now, this is the same, Shabab, if you did it by integral. We will do that after studying the fundamental theorem of calculus. We will see later that this is just x to the power 4 over 4 minus 6x squared over 2 from 0 to 3. But of course, in these sections, we need to do it with using the Riemann sum, because you will have questions about that in the first exam. Now, as I said, Shabab, now the integral here is negative. What we mentioned there, what we have found is negative. So it is indeed, it is not equal to the area between this curve and the x-axis. What is it? The integral, this integral cannot be interpreted as an area because if here takes both positive and negative values, but it can be interpreted as the difference of areas. What is A1 here? A1, it is the area above the x-axis minus the area below the x-axis. طبعا, if you want to find the area in this case, it is just a matter of taking the absolute value. It will be the integral. We will see that later when we calculate the total distance traveled. In fact, if you want to find the area A1 plus A2, it is indeed this one. So it will be the integral, and you can find that from here to here. I don't know what is this point. I think it is x cubed minus 6x. It will be x squared minus, it is the square root of 6. So it will be the integral from 0 to the square root of 6 for negative x cubed minus 6x. Why negative? Because the function here is negative. plus the integral from square root of 6 to 3 for the integral x minus 6x. It is positive. If you calculate this, it will give you the area, which will be, of course, the area here plus the area here. We will do that, Shabab, later, not now. This is not our subject in this section. We will focus on it later, I think, when we find in 5.5 and 5.4. Now, example 3, set up an expression for this integral as a limit of sums. This is very easy. You need just delta x. This is f of x. Your function is this one. This is a, this is b. Okay, now find delta x. Delta x, it is b minus a over n, so it is what? 3 minus 2 over n, so it is 2 over n. This is delta x. Now xi, what is xi? Xi, it is 1. Xi is a plus I delta x. A is 1, delta x is 2 over n. So this is xi. Then find f of xi. What is f of xi? It is e to the power xi. So it will be f of 1 plus 2 over in, which will be e to the power 1 plus 2i over n. And this 2n is a constant. There is no I here, so you can take it out. And this is, of course, what he wants me to do. Set up an expression for this as a limit. So this is as a limit. We can do that later as a definite integral very easily. Okay. Now we don't have a specific sum for this form for this sum. Done. Now evaluate the following integrals by interpreting them as sum of areas or in terms of areas. Now how to find this integral? You cannot, يا شباب. We will not be able to find this integral. الشباب اللي قاعدين يقولوا integrals, we can use integrals. You cannot find this integral until we study chapter 7. In chapter 7, we will see how to find this integral. But now we can find this integral now by using areas. How to do that? Now you need to ask yourself here, what is our function? Our function, it is y equals to what? 1 minus x squared. So this is the function that we are integrating. This is f of x. Okay? We are integrating from where to where? We are integrating from 0 to 1. Now, if you notice here, just look at this. If you square both sides, you can see that this is just what? It is a circle. But you know, Shabab, when you solve the equation of the circle, you will have y equals to positive or negative the square root of 1 minus x squared. So this one is the positive part. Let's go and sketch the graph of this circle. This is the circle. 1, negative 1, 1, negative 1. This is the center at the origin. Now the upper half here, the upper half from here to here, it is y equals square root of 1 minus x squared. The lower half is y equals to negative 1 minus x squared. Now this represents indeed the upper half, but not from negative 1 to 1, from 0 to 1, so from here to here. So just we are calculating the area of this. It is positive, it is above the x-axis. So we can think about this integral to be the same as the area of this region, because it is positive in this case. So this is equals to what? This will be equals to the area of this part. What is the area of this part, ya shabab? Do you remember what is the area of the circle?
No, yes.
The area of the circle, it is by r squared. What is r in this case?
1.
It will be by times 1 squared. So it is by. In this case, this is it the half of the circle or the quarter of the circle?
1/4.
So this is quarter. This is the fourth. So it will, the area in this case will be 1 over 4 by r squared, which will be by over 4. So this integral equals to by over 4. Simply like that. We will see that later, ya shabab, when we study chapter 7, how to do it in general. طبعا, if it is from 1 to 2, from negative 3 to 2, you cannot apply this. This is only when we have it. طبعا, I will summarize this for you later.
Doctor,
How to do it when you have it from different values. Yes.
can we use here sigma to solve? limit.
You can use sigma. It's not easy at all. No, it is not. It will take time. You cannot find it exactly. Try to do that. Yes, you can, of course, but it will not be easy at the end to find the sigma, the summation, how to deal with the sigma in this case. It will not be easy. How to find the limit, it will not be easy. But of course you can. This is, ya shabab, just how to use the areas. It is important to learn how to use areas to find the integrals, the definite integrals. Let's take another example, but this example is easy. By the way, this is easy. You can solve it easily, ya shabab. This one, it is just the integral. We will see that later. This is so easy. The integral of x, it is x cubed, x squared over 2 minus x from 0 to 3. And we can do it easily. But also you can do it with the help of areas. How to do that? The idea is, look at this line, x minus 1. It is a line. This is the function that we're integrating. If you sketch the graph of this line, here it is. From where to where, by the way? From 0 to 3. This is at 0. When x is 0, you will have -1. Here it is. And when x is 3, you will have, when x is 3, you will have 2. Here it is. So this is the line. And the integral here will represent the area between this line and the x-axis. Indeed, we have here from 0 to 1, it is negative log, because it is equals 0 at 1. So before 1, it is negative. After 1, it is positive. Now, if you want to represent this integral from 0 to 3 as an area, it will be the area above the x-axis minus the area below the x-axis. Now, can you know what is the area above the x-axis, ya shabab? What is the base? It is a triangle. The base is what? What is the distance from here to here? It is 2. And from here to here, it is also 2. So A1 will be just what? A half times 2 times 2 minus, what is A2? A2, the distance from here to here, it is 1. The distance from here to here, it is 1. So it will be a half times 1 times 1. So this will be what, ya shabab? It will be 2 minus a half. So it is 3 over 2. 1.5. Okay. This is an exercise about how to compute this integral. طبعا you can do it, ya shabab, compute it by using the Riemann sum. Then find the area under this curve. So let me just show you quickly how can you do it in general by using the Riemann sum. You need to find what is delta x, which is b minus 0 here. It will be b over n. Then find xi. Then f of xi. Then multiply f of xi by delta x. Then you can take b squared over n squared out because it is a constant. Now you can just notice that this is of course n times n plus 1 over 2. Now simplify, take the limit. In this case, the limit here, this will be 0, shabab. The limit will be b squared over 2. Now we can generalize this, the integral from 0 to b for x dx. It is what, ya shabab? It is b squared over 2. Keep this in mind. Khalas, we can use it always because we have proved it. But indeed, we can do that with the help of areas much easier. If you look at this line, it is this one. From 0 to b, let's say this is b. B is positive in this case. Now, the integral, because here the region is above the x-axis and the graph, of course, it is above the x-axis. This area, it is equals to the integral. Or in other words, the integral from 0 to b for x dx equals the area here. What is the area of this, ya shabab? It is the half. What is the base? It is b. What is the height? It is b. So it is b squared over 2. The same. So the areas can help us, ya shabab, so much to find the definite integrals. What I want you to recall now, what is the integral from 0 to b for x dx? It is b squared over a. This is an exercise. I'm gonna leave it for you, ya shabab, the same way. This is similar to what we have done before. This is just the half or the semicircle. How to find it? The final answer is there. And also this one with absolute value. You need to record the absolute value from -1 to 1. How to find the area. Use also the ideas that I have mentioned before. And we will continue tomorrow, inshallah. This is all what we have for today.